Alright, so here we are with a video that has audio. Sorry about that last one. I think that was obviously the problem. We didn't have the audio turned on. In any case, here is the formula for circles that I talked about in class. Some of you might remember seeing this in geometry. I don't really know how much of it you worked with though. This formula is going to be actually really important this year because obviously trigonometry, we're going to talk about circular motion. In any case, here's an example of how you would graph an equation like this on your calculator and how you'd find the x and y intercepts both by hand and using a calculator. So let's just go ahead and do as much as we can by hand. So just like you guys have been doing with your other functions, if you're trying to find your x-intercepts, you're going to leave the equation like it is. You're simply going to plug in 0 for y and solve for x. So if I go ahead and plug in 0 for y, I see that this side can't be simplified, yes. Here we have 5 squared, so that's going to become 25. Subtract 25 from both sides. I'm going to get negative 16. Now in my next step, I see that I'm going to take the square root. And if we take the square root of a negative value, well, first of all, any square root, we get plus or minus. But the square root of negative 16 is 4i. Now right here, I could add 3 to both sides and get positive negative 4i plus 3. But this is an imaginary value. Therefore, this graph is not going to intersect my x-axis. So no x-intercepts because we didn't get out real numbers. Now, to find my y-intercepts, or maybe there'll just be one, we repeat the process, but this time we plug in 0 for x and we solve for y. So this becomes negative 3 squared, which is 9. Subtracting 9 from both sides, we get 0. If I take the square root, now there's no sense in putting plus or minus 0 because there really is only one 0, okay? So in this case we can just put 0, add 5 to both sides. So here I got a real value out, so therefore I'm going to clarify that my y-intercept is the point 0, 5. So we'll want to confirm these two things when we graph on our calculator. Now the next step is to actually get this equation into a form that we can enter into the calculator. So we know we have to get y by itself. So I'm going to start by writing the equation out. So anytime I say solve for y, it means basically isolate y. So we want to get y by itself. Now before we can do that, eventually we're going to be subtracting 5 and we're going to be taking the square root, but first we've got to bring all of this over to that side. So I'm going to subtract this entire expression from both sides. So it cancels from this side. On the left-hand side we still have y plus 5 squared. Now this looks really weird. Don't do anything crazy like starting to distribute the minus sign. Otherwise you're basically doing subtraction before you do exponents. Just leave it like this, okay? Remember guys, we're just trying to get this y by itself. So the next step that I'm going to do is I'm going to take the square root of both sides to get rid of that power of 2. That's going to leave me with y plus 5 on this side. Because I did the square root, I have to include both solutions, the positive and negative value of 9 minus, in parentheses, x minus 3 squared. And the last step, I'm going to subtract 5 from both sides. But when I subtract 5, it's the last step I'm doing, so it's going to have to go outside the radical. So again, here's the y we're trying to get. Finally, y's by itself. We get plus or minus the square root of this entire expression, 9 minus x minus 3 squared. And then outside of the radical, we have our minus 5. So like we talked about today in class, when you have the situation of plus or minus, you actually have to enter into your calculator 2 equations. You have to enter the positive part of your graph, so that's going to be, now I'm going to write this in my calculator. When I enter this, I'm going to put everything that's under the radical in another set of parentheses. You're going to want to do that into your calculator. You don't really have to do it on your paper here, but I'm doing it so you can see how many parentheses I'm going to be adding into my function in my calculator. And then into y2, you're going to put negative, not minus, you're going to use the negative button, and enter the exact same function. So again, when I enter this into my calculator, I'm going to put parentheses around everything that's we're taking the square root of, and around the x minus 3, since only the x minus 3 is being squared. So when I go ahead and enter it, let me show you how that looks in my calculator. Notice the two sets of parentheses here and the minus 5 on the outside. When I press graph, there's my circle. And again, it doesn't look it's complete, but it is a complete circle. If yours didn't look like this, if it looked more rectangular, you can go to the zoom button and go zoom square, and it should make it a nicer looking circle if yours didn't look very round. In this case, we can clearly see there's no x-intercept, so that's been confirmed. Now for my y-intercept, there's a couple things we can do. The best thing to do is just, as long as you can see a y-intercept there, go and use the calc function and then use the value function. So it allows you to plug in any value for x and it'll give you the y value. So we're curious, when x is 0, what is y? Sure enough, it's at -5. Or as long as you can see it in your window, you can actually go to your table. Actually, you don't need to see it on your table, and go to 0 and confirm that y is -5. Sorry, on the last function that I did, when I used the value, you have to be able to see that value. So right now I couldn't plug in, since my window only goes to 15. Watch this. If I tried to say, what is the function output when x is 16? An error reading comes up, and the reason why is the graph can't see 16, so I'd have to change my window. So quit. This is if you encounter this. So if I change my window, watch, to include at least 16. So let me actually just go to 17, and I go back to my graph. Now, if I press second calc, what is the function when x is 16? Now it's going to not come up with anything because my graph doesn't touch when x is 16. The y is just blank, meaning when you plug in 16, you're not going to get out a real value. You'd get out an imaginary value. In any case, this should help you on the last problem on today's problem set. We're going to be doing a few more problems tomorrow, continuing graphing, doing things by hand, but also using our calculator to support our work. Alrighty, you guys, have a great night.